Thank you.
Thank you, Michael.
Good to go?
Yes.
All right. All right, hello. Audio synthesis in the browser with Wax is the title for this. Hello, my name is Michael Cella, he, they, and I make music under the moniker Nnirror. And in that project, I build algorithmic art software and then I make art with it. So it's kind of in a creative feedback loop where I'm exploring a lot of the corners of the own stuff that I'm making to make my art with and to build software with. There's my website. Recently got an MA from University of Michigan. Here are some things that I have made, just to give you some context on my background. So this is what I'll be using later tonight in my performance. It's called Facet. It's a live coding system that is able to synthesize audio, MIDI, OSC, and images. And it's free and open source. It runs kind of between the browser and Node.js processes. So this is the text editor interface in the browser. And I've also made a fair amount of Macs for live devices in the last 5 years or so. I've been doing Macs for I think 12 years now. So the first 5 or 6 were kind of like woodshedding, as they say. And I've been more public facing lately. There are a lot of kind of open-ended devices. Kind of the goals of some of these, like for example, this is a video-controlled granular synthesizer. This is an image resynthesizer into the audio spectrum. This is a fractal explorer that can be either like an audio wave shaper or a control voltage generator. So just various sorts of open-ended things for generative music like that. When I was in graduate school, I did some work in hardware and instrument hacking. I'm not an expert, just kind of having ideas and having the time to explore them was valuable. So these are some of the things that I did in graduate school, like installations with Petoskey stones, which are an ancient coral that's in the form of a rock, and building circuits, connecting things to prepared turntables and 3D printing stuff and hamster wheels and stuff like that. But the topic of this talk is about a browser-based audio synthesis environment called Wax. So that's what we're going to be kind of zooming in on in this. And let's do it. So here's the plan. Just to kind of first set the stage with motivations and influences and concept behind Wax. And then I'm going to spend a lot of the talk just live coding kind of demonstrations of some of the things you can do with Wax. And then I'm going to ask all of you to pull out your phones and we'll do a little group performance. And then I have some reflections to share. So Wax is located at wax.bz, and it's a free open source web application for audio synthesis. It runs in the browser, and you don't need to install anything. And you can go check it out whenever you want. The influences, flow-based programming, obviously, like Max, even in the name, it's like kind of the Waluigi of Max, one might say, or the web version of Max. So that's kind of where the name came from. Also, Pure Data and Reactor. So just the idea of modular synthesizers, which were the kind of predecessors of flow-based programming, is really the hardware implementation of that, where you're connecting building blocks that have outputs and inputs and designing your own flow of audio and control rate signals. And then also another influence is live coding tools that are accessible on the web. So Strudel, obviously, as Will has mentioned and others have performed with in this conference, as well as a couple things that haven't been mentioned yet that I think are really interesting. So one is this tool called Cable Salat, which is developed by Felix Roos, who has also been involved with Strudel. And just to quickly open that up, it's a live coding environment that allows you to define an audio graph in a single audio worklet. So essentially you write this code and then it compiles into one audio worklet, which can do some really interesting things because one audio worklet has no minimum on delay time. So you could write like single sample delays and do kind of crazy FM with that. And Cable Salat is actually based, it's kind of like forking some of the functionality of Noisecraft, which is another flow-based audio application. So you can kind of see it looks like has the same paradigm to Maximus P or Pure Data, where you have different black boxes and you can connect them. And another influence is just modern web browsers. There's a lot you can do with Web Audio API these days. WebAssembly and audio worklets can compile to run really fast. And one way that I got into this was, since I mentioned I had been doing a lot of work with Macs previously, when they put out Rainbow, there is an export target, which means you can basically take the DSP code that you've written for Macs and then export it to run in another context in the target. So in this case, I'm exporting Macs code to run in the browser as an audio worklet. So this was all kind of like swirling around my mind while I was starting graduate school. And I guess maybe I'll back up a second. So the idea really is just to add devices together in a workspace, connect them together. All the connections are digital audio signals, so even if you have like a slider and it's outputting a control rate, it's an audio rate control rate. It's just numbers that are kind of, it can be any number, but it's still an audio rate. If that doesn't make sense, it's okay. I guess another core concept is that you can save and share patches with other people. So you can kind of save the state of your patch as a URL and share it as a URL, or if it has, like, say, audio files that you've loaded into it, you can save all of that into a zip file and then share it with someone else, and they could load it up on their machine. So here's just an example device. This is the sine device. Here is, like, I'm kind of going around the resulting device in Wax, but here's the max code that I use to generate it. So it's really like just a wrapper for a sine wave, like a cycle object in Max. So there's an inlet, there's another inlet, there's a third inlet, and you can see over here in resulting in Wax, those three inlets are corresponding one-to-one. There's one outlet, and there's one outlet. So it's basically taking DSP that's existing in Max and porting it to run in the browser. This is just a figure from the paper I wrote, but yeah. So why build this? I really, like, it comes down to sharing. Previous systems that I built were hard to share. I built a Max MSP-based system from like 2016 to 2020 or so, and it was very, very specific to my setup. It tied into hardware that I had, and it had a very high CPU baseline. That's not due to anything in Max particularly. It actually has to do with, like, the initial assumptions I made when I was designing it, because I was, like, learning Max simultaneously. It also, Max has a paid license, so that does limit whom you might share it with. Facet is also difficult to share, but for different reasons. So it requires the command line, it requires someone knowing how to install software like a Node.js or NPM packages. So even though it's powerful in kind of all sorts of weird ways, it might be hard for a beginner or someone without terminal experience to want to install it. And it's also not super efficient. So even if you did all that stuff, sharing like a simple, how do you just make a sine wave play at 440 hertz till the end of time, it would take explanation and it wouldn't even make sense to them, really. So anyway, the goal was to build something with a low floor, high ceiling, immediately accessible, CPU efficient, and live codable. So to kind of incorporate some of the stuff I'd learned by building Facet. Use cases, you can imagine, like, especially in educational contexts, like, people can just immediately pull up something on their phone. So if you build something and wanted to share it with them, or students, especially nowadays, I think they really prefer the path of least resistance. They don't want to install things necessarily, and so this is a way for people to kind of immediately access audio synthesis concepts with the existing tools that they have. Also, you can imagine scenarios where you're on a train, or you're on a hike, or you're I don't know, doing something where you couldn't have a synthesizer or a desktop computer with you, but maybe inspiration strikes you, or you want to explore, like, the outer limits of what you can do while synthesizing. So for example, like, you could, and I have taken a skateboarding with a phone in my hand and recorded things and kind of sent it into a vocoder that I built in Wax. You can also, there's as many output channels as there are whatever the DAC that you've connected to is. The browser just natively has however many output channels your digital audio converter has. So you could do multi-channel audio setups or installations. And then honestly, the most important one for me is just making music, jamming. Okay, so that's the overview of Wax. Let's build some stuff. Demo 1 is just like basic audio synthesis. So I'm just going to open up Wax. And here is the user interface. So first comment I've prepared for myself here is just to say to add like an oscillator and a filter. So let's add a sawtooth. And maybe I'm going too fast. So I press N, And then there's a little kind of autocomplete. You could also select a device from this devices dropdown, but once you kind of know some of the devices, and a lot of the interaction paradigms come from Macs, so I've borrowed some of the like key combinations and things like that to keep the flow similar. So here's a sawtooth oscillator, and here's a low-pass filter. Connect the output to the input, connect the input to the output, etc. I'll turn this up to like 120. Hello, world. So that covers like 1 and 2, connecting devices with patch cords, then parameter control through the HTML inputs. So if I go and add the sawtooth back, you can see that I'm changing the frequency by just typing in numbers here. Is this too small, or can you all kind of follow along? Yeah. Okay, so that's the when there's nothing else connected to an inlet, like say, for example, frequency, you can just type into this input box and it will then change when you do that. But what takes precedence is if there's a signal connected to it, then it'll kind of switch to that. So say I connect a slider, for example, and I make the minimum 10 and the maximum 200, and then I connect the output to here, it should immediately like switch over. Connect this to here. So even if I change this number, right, whoops, nothing's gonna change because of the connection. If I remove it, 40, yeah, okay. Then you can, if obviously like when you're building digital signal graphs, you need to be able to debug your work. So there's an oscilloscope. I might turn this down since it's just straight noise. That's not too loud, right? A little quieter. There's a spectrogram, a spectroscope. And there's a third one called print, which just is more for like control rate debugging if you want to see like the numbers that are coming out of a device, but not at audio rate. I'm not going to demo it immediately, but that's print. Okay, that's demo 1. User interface, just to kind of go through some of that at the top a little bit. So on-off button, pretty self-explanatory, just if you want audio processing on or off. Then there's a lock or unlock button, which means that if, for example, if you never want to accidentally delete an object in your patch, you can just lock it, and then this won't get deleted, which is helpful if you're trying to like perform for a little bit with it. Then if you want to save a patch to a zip file, you can click this and it'll collect all the audio assets. Like, for example, if you have a play device in your patch, which can either have like a URL for an audio asset that's online, or if you want to pull something from your computer. Basically, this will just save into the zip file when you save it. You can load a zip file with this. You can share as a URL, which will kind of collect all of the devices in the patch and share it as a URL, with the caveat being that any audio files in the browser will not be included because the URL would be too long if it were to include all of that. I suppose, though, if you use a URL, then it would be shared because then it's just kind of metadata and it will kind of asynchronously pull in the audio when the patch loads. I'll go over this collab button a little bit. Then I showed devices already. There's some examples that come along with this, so you can kind of hit the ground running, I suppose, and then just a little about that shows the first time you load it. Okay, demo 2. Demo 3, MIDI input. So there's 3 different ways you can get MIDI input. There's MIDI notes, which just listens for MIDI notes. That's all through the web MIDI API. It's not the most elegant implementation because of kind of some initial assumptions about how I wanted to design this, but another kind of reflection on that later, so I'll just leave it at that for now. But essentially you can see that like there's 8 voices and then there's 8 gates. So you can at one time have up to like 8 simultaneous MIDI notes playing, and you could use that to play chords or do whatever you want. Whenever a voice is played, it kind of goes to the lowest number here, so there's like a voice stealing kind of thing going on. And anytime a note is played, the corresponding gate will be open or closed based on note on, note off. There's also MIDI CC, which allows you to have kind of like control over parameters in your patch. So in this case, I have it listening on channel 1 for control change number 70, and it's just connected to a filter. But yeah, imagine you have like 30 of these in your patch or whatever, you can do some pretty complicated things, with the caveat being that the bit rate on MIDI CCs is, I forget, like 8 bits or something, because there's only 128 possible discrete values. There's also MIDI pitch bend, but I'm not going to demo that today. If I just kind of pull up this magically prepared Facet session with 2 commands here. One will play notes and transmit them to Wax. The other is for MIDI CC. So if I start with CC and then kind of show you with a print object, you can see that it's a ramp from 1 to 0 over 128 values, and then it's echoing 7 times each time it gets a little smaller in amplitude. So it's definitely receiving that. And okay, now I'm going to play the command to also play MIDI notes. So yeah, obviously you can imagine that you could live code this, but just to make sure I don't go over, leave it at that for now. You can do a lot of stuff with MIDI. And I think maybe one other thing to note about MIDI is just that, like, imagine you had a physical controller, like I'm kind of maybe not cheating, but taking a bit of a shortcut by using everything in the box here, but say you had like a fader box or some, even just like MIDI keyboard, there's a lot you could do to sort of just have that and your computer and build your own weird thing that you could share or whatever. Okay, demo 4. You can access the microphone through Web Audio API. So in the interest of not having feedback, I'm going to really probably just not even connect it and just do this and show it in a scope, but not play it back. So hello. It's there, trust me. You can also load audio buffers, which I already talked about a little bit, and then there's multi-channel audio output, which I've also already talked about a little bit. Essentially, if this, currently I think there's probably just 2 channels connected to this audio output device, but if there were more, then I could increase the channel number here, and you can go quite high. I think the maximum that I've seen on Web Audio API is like 32 channels. I myself have done 16, and there's a video here that I'm going to play, and it's quite loud, and I'm going to immediately pause it when it opens, and then I will play it at an appropriate volume. Oh, that's not too bad, okay. Okay, that was the part of the talk I was most nervous about. So this is my phone. This is like an early version of Wax, like 2 years ago, and it's connected directly to an Expert Sleeper's Eurorack module, and basically transmitting 8 channels of control voltage from my phone through to this module, and then from there into 8 different inputs of this FM synthesizer. So essentially like directly controlling a FM drum synth from my phone. I'll just play a little bit of this. So you get the idea, it goes on. Thank you. Okay, that's demo 4. Let's see, actually, there might be one more link I didn't click in here. So you can load audio buffers and maybe want to be, okay, here's another patch that I prepared, so I should probably show it to you, right? Here's 2 buffers that are just being pulled from archive.org. They're like breakbeats that are somewhere on the internet that I just pulled in. I'm not going to get into live coding yet. Suffice it to say, you can pull in all sorts of stuff from archive.org, right? And then share it with your friends, and really that's, I think, the magic of like the URL sharing is that you could have something and just immediately put it on the internet, and then it might have someone else pick it up and do something with it. All right, Demo 5 is based in kind of some really interesting other work that I kind of heard about in the last 5-6 years. I'll just say 6-7 years just to like make that joke. But so my kids are that age. So the first one is Intersymmetric XYZ by Mark Fell, Ryan Trenner, and James Bradbury, which was, I think it's still online, but it's this really amazing collaborative website that you can go to and basically like jam this almost like acid-style drum machine with whomever else is in the room. I think there's like 4 different rooms, and I think they initially put it out in 2020. It's really awesome because it, I think, is what's good about the internet. You can actually like virtually hang with people and be creative with them, and there's no usernames, there's no passwords. It's just kind of fun. Also, Noodle.cc, which I think is currently dead. It's it's in this like constant death rebirth cycle, which is awesome. They also kind of have a very, I would say, free spirit in terms of like letting code die is one of their big mantras. So Noodle.cc is basically a collaborative live coding space where people can all join the same session and either do visuals or audio stuff together. And there's this group of people that do this work under the name Pasta Gang, which is this, they're all like dispersed throughout the world, but they will play DJ sets in real spaces. And I find this sort of real-time collaboration stuff to be really interesting just because, again, like what can the internet do? What are the fun things that we can do with the internet? So I'm just going to do a very kind of simple, quick demo with that now. So open monosynth example, it tells me to do. Then I'm going to click the collab button and create a new room. It should copy the patch state into this new room, which you can see here. And then I'm going to copy this. And since I'm on the same Wi-Fi, I think it should just like automatically transfer to my phone. It did. Okay. So now I've got it up on my phone, and I'm just going to play the synth from my phone. So, the audio is coming from my computer, right? But, anyone else could join this room right now and mess my patch up. Don't do it. All right, so let's go play C unison. There's only one note. Because I've moved it to be only in C. I'm sorry for the C major demo, but it's kind of like a cliche that just continues forever. So now it's just C and F, right? Pythagorean scale. Yeah, there's like a discrete number of nouns and adjectives, and they just get kind of randomly slopped together when someone joins. So I'm fuzzy rock. No, this is fuzzy rock. I see fuzzy rock on my phone. You don't get to see fuzzy rock. I will say that is something that is working pretty well, but I think it's kind of more, it might need a little more, it might need more work. It's not as far along as some of the other features, but, far enough along to be able to do that, so yeah. Okay, and then a last demo. When I was building this, it kind of initially came from how do I extend Facet, how do I extend the live coding environment into something that I could share? And so I still ended up kind of finding a way to, and was really interested in finding ways to extend Facet. And so a big part of this, and it's been in some of the states I've already shared, and will be in others, it's in this state too, is that there's this device called Pattern. And it's also true for any of the HTML inputs here. You can type an expression in Facet and it will evaluate to whatever it resolves to. So like it could do any JavaScript, so it could just be like math random times 20 or whatever, But the pattern object is a way to essentially have like a live coding intermediary in the signal flow. And so essentially here what's happening is there's 2 inlets. There's one for reading the phase. So you can almost think of it like a wavetable, right, where you're just reading through it with a phaser. And here I'm telling Facet, like ramp from the Nyquist number, which would be 22,100, and to ramp to 0 over 16 values. and then echo that 31 times, so it'll just get smaller and smaller and smaller. But with a pretty high feedback coefficient. Anyway, I'm going to change all these numbers so you can actually see what live coding is in this context. But if I run this and then toggle this on, ultimately what it's doing is it's like, there's just this little bandpass filter using FFT that's like filtering noise. So it's just a 100 hertz wide bandpass filter that's getting moved down the audio spectrum. Ooh, that's so beautiful. Music. Okay, so yeah, like it can be a live coding wavetable, right? That's like in the middle of the signal flow, which means that, like as Tom was talking in his previous talk, like in Max, one thing that's tricky is that when you want to make a change, you have to unplug something, right? In this case, you can, if you build a certain type of patch, you can keep the signal flow the way it is and still have this weird layer in the middle that allows you to improvise wildly. Here's a couple other examples. So you can load buffers. So here I've loaded another sound from archive.org. And if I play it, and you can live code. So this is loading audio, right? And it's loading it into this wavetable. And this second inlet, instead of for like reading by phase, you can just trigger the audio. So it's kind of specifically for audio, but say I do delay MS 250 and then give it a high feedback coefficient. So yeah, you can kind of load in the audio buffer and do some interesting stuff with that. I will say though that Facet runs like, especially here in the pattern object, it's like all CPU-based computation, and it's in a web worker, so it's not like this magical thing that can extend forever. Like it's for a specific kind of range of maybe a couple seconds of audio, and even say, for example, if I do like reverb here, this might tell me like maximum call stack size exceeded. So there are certain like things that you just can't do, but it's okay. It just tells you nope. And then lastly, well, this is, similar to this one, but this is just straight up audio. So I guess this was control rate data, right? This is only like 16 values echoed 7 times. That's like, 128 values. Whereas this is loading a wave file from elsewhere. This is synthesizing a wave, or enough data to be audio itself. So run that, and then it's connected to a phaser that's reading through it at 1 time a second. Turn the mute off. It's a kick drum. So you can definitely build some really interesting kick or percussive things. Say you had like 5 of these and they're reevaluating every once in a while and there's some randomness in your code. So a lot you can do with this pattern object. And okay, that's all the demos. It's time to perform. If you would be so kind as to pull your phones out. All right, let's become a distributed electroacoustic ensemble, which is like fancy academic speech for like, let's just do this. Okay, if you have an iPhone, make sure to turn silent mode off and set the volume to the maximum. Then open this QR code, and if you're not on Wi-Fi, I checked there's decent service in here, so hopefully it will still load up. But then it might take a minute because it just needs to like load all of the different generators and such, but then it should start sounding like a harp. You should also allow device motion access so that you can access your phone's accelerometer data. Allow me to indulge you in just a quick video before I also do this. Thank you. There will be more structure coming up, so hold on to your hats. Okay, do we all feel ready to go on to the next? Okay. I'm just going to be silent for the rest of this, and we'll just read the instructions on the screen. Sound good? Because we'll really try to make like music, all right? We did it. Thank you. Appreciate everyone so much for doing that. Thank you. Signed into FaceTime. Get out of here. I got better stuff to do. Okay, just a couple reflections. This is something that has been mentioned, I think, a few times. I brought it up in conversation. I feel like other people have also brought it up in conversation. This is just my own little, fancy theory, but I feel like we are at a point where there's these paradigms of audio synthesis that are hybridizing. So, for example, with text-based systems, we have user interfaces beyond text. There's sliders inside of Strudel. There's other elements inside of those sorts of systems as well that are not text. And then you also have flow-based systems like Macs that have started to have code boxes everywhere. Wax is also, I would say between the two. But to take a step back, maybe my theory as to why that is, why it's good to hybridize, why that's happening, is that in flow-based programming, you have direct control over the DSP in real time. It's very low level, but it's also less flexible. If you want to make a big change, it means you have to rewire connections, and maybe that's either too slow or will make a click, or it's just maybe a little less convenient than it is when you're live coding, which is a higher level of abstraction of control into text, which makes it more flexible, but means that you have less direct control. And so why not both, right? It's good to have both. Another reflection is that culture continues to become, as this quote by Miller Puckett says, increasingly transmitted in functionality and not in passive documents. We really do see nowadays that web-based art systems we just did it, right? We downloaded, modified, shared, reconstructed, and kind of did a whole thing in less than 10 minutes, which shortens the feedback loop between creating culture and distributing culture. I also really want to stress that there's so many things that are not perfect or not great about Wax and the systems that I develop. And just for a few examples, one is that the way to undo in Wax is very, very hard to understand, and in certain cases it's not possible. So when you have HTML elements, like here, this is an HTML element, it comes natively with the browser. If I type something, you can automatically undo because the browser affords that to you. But I can't delete this thing. There's no way to do that in Wax. I haven't figured out a way to make it play nicely with the sort of native DOM, native browser functionality. It's not a bad thing, it's just the way it is. I also think being an extension of modular synthesis, that's exactly what happens when you have a real physical device. You plug something in, it's there until you remove it, right? You can't undo it unless you take it out yourself, so it's not so bad. Then it's also not possible to make an abstraction in Wax. You can't just select a bunch of devices and group them into one thing that you can then reuse. It's all a one-to-one relationship between what is on the screen and what is actually running in the audio graph in your browser. And not that that's a bad thing, but it does mean that there are certain types of patches, even the MIDI one where there's 5 little sawtooth voices, it quickly can become unwieldy for certain types of synthesis, but it's not for everything. So it's more for sketching, it's more for having fun and sharing weird kind of stuff that you can do across the internet. But basically in both cases, these trace back to some initial assumptions I made, and that's okay. I also want to just mention accessibility. So one goal with this tool is to help to make it possible for people to access these sorts of things, but I will still say that even with that intention, even with the best intentions, it's quite frequent that the tools end up, even if they're available, they're still kind of have all these assumptions about, about audio synthesis, you know how to make a connection, and you know how to debug, and you know what a spectrogram should indicate, and so it's available, but I would say there's still a lot of work to be done to make it more accessible. I've worked on documentation, I've made some videos, but there's still more to do. Another point is and this is something that's especially true at a festival like this, is that people have their own systems and they get very complex over time, and it becomes hard to document and explain. So it's the Tower of Babel situation where everyone kind of is speaking a different language. And this is, I'm offering it as another thing on the pile of all the other things that you've heard about, and I like it, but that's just a thing I wanted to mention, is that we all are coming at this with kind of, I think, just some, not bridges between us, but there's always, I think those are both opportunities and also things that just need to be recognized. It's good to recognize them. Lastly, free and open source doesn't guarantee accessibility, so, all of these things are crucial, and I've tried, but it's hard. Okay, the work is never over. Just iterate. These are just more like lessons learned, I guess, at this point, but I really think that the goal there is no end goal for a lot of this stuff. I'm gonna continue building these things, I'm gonna continue working on them, and there's no real end. It's just iterate and continue to make decisions. These works are huge accumulations of subtle decisions. And here's a great quote that I love, is instant music, subtlety later. When you're building things, don't get stuck on a little detail, just get it working first, and then slowly think about ways to make it maybe a little bit better. Kind of continuing, extending on with that is you will forget and neglect things. If you're going deep and wide to build something, there's going to be parts of it you built a year ago or months ago, and you just have to kind of get comfortable with a form of incompleteness, and that's not a bad thing. Okay, last lesson is just that I think it's very important to consider playful approaches to technology. I have 2 kids, and I was building Wax while they were younger, and I just think that it's important to think about how children, when they're older, will think about the technology of today. And we all know that modern phones are really, really, really powerful. I just showed that video where you can go play a modular synthesizer with it, but I think 99.999% of the time, that is not what we're doing with our phones. They don't feel fun. You have to log into everything, and I'm not gonna beat you over the head with that, because I think we all that's the day-to-day of our how our phones are, but it is important to imagine other futures, and I think Wax kind of is in that ethos. Thank you.
That was super fun. Wax looks so good, and that was such a good demonstration. Really nice to have everyone involved. We do have some time if people have questions. Anyone?
Yeah, kind of a basic question. I was wondering what the I/O to get the MIDI in actually was, because I saw you had Facet in one tab. Is that going over the internet? Is that local? Is that something that the web audio can just snoop on somehow? How does that work?
So you can see there's the IAC driver bus here. So it's a virtual MIDI. Sorry, you probably can't see it because it's behind me. 1 second. So in Facet, you can select MIDI output destination, and I've picked this virtual MIDI driver, which just kind of transmits it virtually across the computer, and Wax is just listening for MIDI events that it can hear, I think, from anywhere. So if I also plugged in a MIDI keyboard, it would receive those as well. So it's kind of just open for whatever things are coming at it. And in this case, yes, it's just going, I guess technically, from the Node.js process, that this is, well, yeah, whatever. Node.js is firing MIDI notes that's going to IAC driver. IAC driver is being picked up by Wax. Does that make sense or answer your question? Cool. Thank you.
What's the regen button do?
That's a good question.
It's just everywhere, man.
So I mentioned that in the HTML inputs, you can express something that isn't a number. It could be Facet, or it could be JavaScript, because Facet is just kind of an extension of a JavaScript. So for example, just to make sure this isn't too loud. Yeah, exactly. And so if I were to type random integer, which is a sort of helper method in Facet, and I do 2 arguments, the low and the high, random integer between 50 and 200. The first time that I run this, it will have already evaluated, but each time I click the button, it'll be a new, right? And I can also just hit enter while I'm focused on it. And so why it's an inlet and not just a button is that you can also have it under signal rate control, and essentially anytime a signal goes above 0.5, it'll fire a regeneration. So you can kind of programmatically make the parameters re-randomize, or they can be well beyond randomness, because you can write Facet in here and create all sorts of different things. So yeah, does that answer your question? Thank you.
Anyone else? Oh, Haley.
Thanks. It's really cool to see demonstrated. I have a question about learnability, and it's not just a wax question. This would be for anything. I'm thinking about in the paradigm, like when I'm using Strudel or other pure live coding, although you pointed out, and this was really fascinating, how visual elements, I forget how you called it, UI elements are getting into code, and how live coding is going into more of a UI or node-based, flow-based. I'm wondering, in terms of learnability, when you make a mistake when you're live coding, per se, and like how that gets presented to the user, and I'm curious, you might have shown it and I just missed it. How do you communicate to someone that's coding in this environment in Wax that they've made a mistake in Wax? I'm curious how that's communicated, and I'm also curious how it's communicated to if you're using Facet inside Wax, maybe.
Yeah, great question. There was one exception that was thrown when I wrote that .reverb command on some audio, but I think that probably what happened is it was like, because it's a great question, the events that when an error is thrown, they basically come up in a little growl notification that's in the bottom right corner of the window. And it's a hard question to answer, because for someone like me who has more background in programming, it's like that, and also that's the same paradigm that Facet uses, where if I write something that's like syntactically invalid, right, I try to run this, it should say something, like you messed something up, so you can see that that's here, right? And similarly, say I do that over here. Do you see error in device parameter 0.5 ASDA? But it doesn't necessarily highlight the place where the error occurred. And I think probably, if you look at the Strudel user interface, there has been so much work that has gone into like highlighting the user elements that are currently active, and things that are honestly like so far beyond I'm honestly like not a very good front-end designer. Like, it's really, really hard for me. And so I would say there's definitely like, just dovetailing with what I said about the digital divide, I think that that's definitely something that like could be made better, if that answers your question.
Well, amazing. Thank you so much.
Thank you.
Yes, big hand, please, for Michael. We'll take a few minutes here to get Carol Lestrito and Cathy Dan Zhang set up. While we'll take a bathroom break and